Hello and welcome. This is Columbia Basin Research's third video in a multi-part series on using Program Atlas, which stands for Active Tag Life Adjusted Survival. Atlas is a program created by Columbia Basin Research at the University of Washington School of Aquatic and Fishery Sciences with funding provided by the Bonneville Power Administration and the U.S. Army Corps of Engineers. Today I'm going to show you how to load in and work with your tag life data. First, let's fire up the program. Type Atlas into the search bar and click it. Pick a single release study. Now, I've already loaded to Atlas the single release Atlas practice file CSV as my capture history data. Previous video explains how to do this in further detail. In order to obtain independent estimates of the tag life correction probabilities, a representative sample of the tags from the study must be set aside, and the failure times of each tag must be recorded. Let me open up a tag life data CSV example. This tag life data file contains the results of the independent tag life test conducted to estimate time to failure for the tags in the study. It is a text file with each row containing the observed failure time in days for each tag. There must be one line for each tag. So if 3 tags failed after, say, 25.5 days, then the number 25.5 must occur 3 times in the file. The first line may be an optional label, which will be ignored by Program Atlas, which is here labeled tag underscore life underscore days. Program Atlas allows for multiple tag life files. This may be necessary when multiple tag lots are used and have different failure time curves. To load tag life data, double-click on Load Tag Life Data and select the desired tag life data file. Repeat for each tag life data file to be loaded. You can see here that I've loaded in the 2 practice tag life files, Vitality Tag Life Atlas Practice File and Tag Life Atlas Practice File. Now that I have my tag life data loaded, I can begin looking at my tag life curves. Click on Fit Tag Life Curve. You can see the tag life data set where I can choose which loaded tag life data to use. Let's look at this Vitality Tag Life. I can also choose a tag life function to set which probability distribution I'd like to use for modeling the tag life failure. Program Atlas provides 4 distributions to choose from. The non-parametric estimator, also known as the Kaplan-Meier estimator, the 2-parameter Weibull distribution, the 3-parameter Weibull distribution, and the vitality survival function. The points on the plot represent the data. The x-axis is the time in days to tag activation, and the y-axis is the portion of the tag still functioning at a given time. Atlas immediately estimates the parameters for the tag life curve and plots the resulting curve in red, allowing the user to select the failure curve that best fit the tag life data. Along the top of the tag life dialog box, there are 3 tabs. The first one, Tag Life Data versus Curve, is the default when the Select Tag Life Curve action is initiated, since selecting the tag life distribution is always the first step. Once the appropriate distribution has been selected, the user may select either Curve versus Data by Detection tab or the Curve versus Data by Release tab. Both of these tabs allow the user to view the arrival timing of individuals as a function of the selected tag life curve. Clicking on Curve versus Data by Detection allows users to look at a detection site of interest for the currently selected tag life data set. The plot will show the cumulative arrival timing distribution for all releases that were released upstream of the selected site, superimposed on the selected tag life curve. If a given release arrives at a site at a point where the curve indicates a higher probability of failure, the user may want to consider excluding that release from the analysis. Curve versus data by release, found here, allows users to select the release of interest and show the arrival distributions for that release at all downstream detection sites. Again, if a selected release arrives too far down the tag life curve, the user may need to consider either not using the release or not using the particular site, along with all sites further downstream. In a well-designed study, the tag detections will occur very early with respect to the tag life curve, on the area of the curve with the high probability of still working, rather than toward the tail of the curve. It may be the case that in the tag life study there might be a few extreme value tags that last much longer than the rest. Extreme values may exert undue influence on the parameter estimation for the tag life curve. The user has the option of removing the extreme values from being considered in estimating the tag life curve parameter. The non-parametric function just follows from point to point. If I click on the Weibull 2, you can see that the curve doesn't fit the data very well. I can try the Weibull 3, but even removing extreme values here won't make this fit the current curve. If I click on Vitality, I have the same problem. But you see here, if I take off these 6 extreme values, I can make it fit. A truncated curve should only be used if all the arrival times are shorter than the truncation point. Notice how much better the estimated curve fits the data. When it's necessary to use multiple tag life curves in a study, separate lots must be assigned to the various tag life datasets. The Tag Pro utility can be used to assign tag codes to lots, or you can manually assign them in the CSV file. It's the second column, also known as the bin column. Within Atlas, the user must then assign each lot to a tag life dataset. This is done by double-clicking on Map Tag Life Data to Lots. This brings up the map tag life data to lots dialog. You can see here, I've currently loaded one capture history dataset and mapped it to the vitality tag life dataset. After selecting the tag life curve, mapping tag lots to tag life curves if necessary, and applying those changes, the user can then estimate tag life corrections by double-clicking on Calculate Tag Life Correction Table. You can see here a menu comes up because I have one tag life data set loaded that I didn't assign to anything. I don't want to use that second data set, so I can click OK. I then enter the number of iterations for the bootstrapping process. The default is 1,000, which is the recommended value to obtain consistent estimates to the second decimal place. Increasing the number of iterations increases the precision of the variance estimate, but also increases the time it takes to perform the bootstrapping process. After clicking through these menus, I wait. It may take a few minutes, which I will not make you sit through here. After the probabilities of a tag being active at the downstream detection sites have been calculated, the user may double-click on View Tag Correction Table to view the tag life correction estimates. For instance, you can see here the analysis is predicting that 97.35% of tags were active at detection site D1. Program Atlas provides two methods for estimating survival parameters corrected for tag life under analysis. Closed form estimates, available under closed form estimates, and modeled estimates under modeled survival estimates, which uses maximum likelihood estimation. Here is the closed form parameter report for a single release study. It is structured the same as the CJS report, but it differs in that the survival estimates are corrected for tag life. The reported survival estimates are the CJS estimates divided by the tag life correction. All estimates and standard errors under the capture details section of the report are the same as those on the CJS report. For the paired release study design and the virtual paired release study design, the closed form parameter report will also report the paired release survival estimate and the extent of damage patches survival, respectively. For single release study design, a cumulative closed form parameter report is available as well and is analogous to the cumulative CJS report. Note that the closed form parameter report is not available if any one of the releases have more than one lot associated with it. I'm now going to do a factory reset to set up a virtual release and load in my virtual paired release data to demonstrate this next section. Because it regards changing parameters across releases, and the single release data currently loaded was obviously just one release. Please see the previous videos in the series for more information on this next step. I've now loaded in my virtual paired release atlas practice file within the virtual release study design, now using a Weibull3 tag life function. Under modeling survival estimates in modeling process, you can now choose equate parameters across release. Given the fact that study designs with multiple release groups are designed so that the release groups encounter the same conditions downstream, this approach may be overly conservative. The equate parameters across release action allows the user to have Program Atlas assume common survival and/or detection probabilities across releases. Reducing the number of parameters in the model may increase the precision of the resulting survival estimate. You can also constrain parameters by double-clicking on that. Numerical optimization algorithms require initial seeds for the parameters to be estimated. Program Atlas uses the CJS estimates as seeds for the parameters, and it is possible for these estimates to be at or above 1.0. Because of the nature of the likelihood function, this can cause numerical optimizer to be unable to estimate the parameters. Constraint parameters action allows the user to constrain the problematic parameters in order to estimate the remaining parameters and the covariance matrix. You can see here under capture that I have a 1.0. I have to check that box, or attempting to compute, the answer will error out. Now I can double click on compute. Once a compute action has been performed, parameter report becomes available. However, near the bottom of the parameter report will be the phrase, "Note, all standard errors are based on only the inverse Hessian." For full standard errors on the survival estimates, perform the estimate full variance action. The Hessian is the matrix of the second derivatives, and under maximum likelihood theory, the inverse of the Hessian is the covariance matrix from which the standard errors are derived. This covariance matrix is based on the likelihood model. The likelihood model necessarily assumes the tag corrections are known without error, and does not incorporate the actual standard errors of the tag corrections as used in the tag correction report. In order to estimate the full variance of the survival estimates that takes into account the variance of the tag corrections, bootstrapping must be performed. The estimate full variance action brings up a dialog asking for the number of bootstrapping iterations. The higher the number of iterations will improve the estimate of variance, but will also take longer to complete. The default is 1000 bootstrap iterations. Once the estimate full variance action has been completed, parameter report will be updated to reflect the full standard errors for all survival parameters. The standard errors for the detection and product probabilities remain unchanged. Under the reports section of the analysis heading, 3 reports may be available: parameter report, cumulative survival report, and the survival covariance report. I just showed you the parameter report here. Cumulative survival report and the survival covariance report are only available with a single release study. Cumulative survival report is analogous to the cumulative CJS report, that it shows survival estimates from release site to release site. A survival covariance report, as with the CJS covariance report, shows values reported in full precision and may be copied and pasted to a spreadsheet for custom variance calculations. I will discuss multi-run mode in a future video when we also directly cover attributes. This has been Lesson 3, Program Atlas, in which we detailed the ins and outs of working with your tag life data inside Program Atlas. Future videos in this series will walk you through single releases, paired releases, and virtual paired releases, and attributes, as well as offering some hints and tips on maximizing your Program Atlas experience. We hope that these videos help you get the most out of Program Atlas. Again, if you have any questions or comments in regard to Program Atlas, please fill out our survey as previously detailed. You can also contact Columbia Basin Research at web@cbr.washington.edu. Best of luck with your analyses, and thank you.